Hey guys, welcome to this video. In this video, we're going to talk about motion in the solar system. And I'm primarily talking about motion of the Earth and Moon. Now as you watch this video, I need you to keep two key definitions in mind. They are rotation and revolution. These are the key ideas to a lot of phenomena that takes place in our solar system, so you really need to understand them well. The Moon rotates or turns around, like the Earth. Rotation is the spinning of an object. Long ago, people thought the Sun, the Moon, and the stars all moved around the Earth. Now we know that only the Moon moves around the Earth, much like the Earth moves around the Sun. The Moon is a natural satellite of the Earth. A satellite is an object that revolves around another object. Revolution is one object tracing a path or orbit around another. When you look at the Moon in the night sky, it does not appear to be moving. It looks like it's standing still in the sky. But the truth is that both the Moon and the Earth are constantly moving, spinning on their axis and revolving around other objects in the sky. Let's review these terms. To rotate means to spin on an axis. An axis is an imaginary line running through the object. In this illustration, the axis is the red line traveling from the North Pole through the Earth to the South Pole. The Earth's rotation is about this axis. So when you think about rotation, think about a spinning top, or think about a globe turning on its stand. Both of these objects are rotating around their axes. To revolve means to circle around a central point. The Earth revolves around the Sun, while the Moon revolves around the Earth. Because they are both spheres, exactly one half of the Earth and the Moon will be lit at all times. In addition, the Earth's axis is not perpendicular to the Sun's rays. In fact, it's tilted 23.5 degrees. You might be tempted to ask, why is all of this important? And that's a good question. The answer is that the Earth's rotation, its revolution around the Sun, the fact that it's a sphere, and the tilt of the Earth's axis all contribute to a number of phenomena that we experience every day here on Earth. They create day and night, the seasons, lunar phases, tides, and solar and lunar eclipses. Let's take a closer look at day and night. Humans use day and night as signals for our daily activities. When the sun comes up in the morning, we get out of bed, we go to school, we go to work, or play. When night arrives, we end our activities to go to sleep. We use the cycle of the day as a way to identify when we should be active and when we should rest. But what causes the changes from day to night? The Earth is rotating as it orbits around the Sun. Every 24 hours, the Earth rotates one time. As it rotates, one half of the Earth faces the Sun, and one half of the Earth faces away from the Sun. The half facing the Sun receives sunlight and experiences day. The half facing away from the Sun is experiencing night. Because the Earth is constantly rotating, the part of the Earth that is illuminated by the Sun is always changing. Take a look. Here's a model of the Earth and the Sun. In reality, the Earth is much smaller than the Sun and farther away. In this case, even though the model is not to scale, it will help us review the causes of day and night. We have placed markers for the U.S. and Japan on our model. Now watch what happens as the Earth rotates. When it's day in the United States, it's nighttime in Japan. This is because the United States is on the side of the Earth that is directly facing the Sun, and Japan is not. As the Earth rotates, the United States moves away from the Sun, and other parts of the globe are lighted by it. In roughly 12 hours, the Earth is rotated far enough that Japan is having day. As the Earth continues to spin, the part of the globe where Japan is located will once again turn away from the sun, and they will experience night. This constant spinning of the Earth is what creates our days and nights. So why do the number of hours of daylight and darkness change during the year? That's a great question. Remember the tilt of the Earth's axis? Let's take a look. In the summer, the North Pole is tilted towards the sun. This means that the northern hemisphere will have more hours of daylight than the southern hemisphere. As this map showing summer in the northern hemisphere indicates, as you move north from the equator, the number of daylight hours increases until you reach the Arctic region where the sun never sets. And as you travel south from the equator, the number of daylight hours decreases until you reach Antarctica where the sun never rises. As summer turns to fall, the number of daylight hours in the northern hemisphere begins to decrease, while the number of daylight hours in the southern hemisphere begin to increase. This process continues until the autumnal equinox, when the number of daylight hours and nighttime hours are equal at every location around the Earth. This occurs because the tilt of the Earth's axis is neither towards the sun nor away from the sun. Therefore, the half of the Earth that is lit by the sun extends evenly from the North Pole to the south. As fall gives way to winter, daylight hours in the northern hemisphere decrease, while daylight hours in the southern hemisphere increase. In the dead of winter, there are days when the sun never shines in the northern hemisphere, and days when it never sets in Antarctica. This is due to the tilt of the Earth. The North Pole is tilted away from the sun in winter, making it impossible for the sun's rays to reach parts of the Arctic. As winter turns to spring, the process reverses. The length of days in the northern hemisphere increases, and the length of days in the southern hemisphere decreases, until springtime, when they are once again equal. At this time, again, the Earth's axis is neither pointed away from nor towards the sun, and the length of nights and days are the same all over the globe. As spring once again turns to summer, the length of days in the northern hemisphere increase, and the length of the days in the southern hemisphere decrease, and the process repeats itself. In this video, we defined rotation, we defined revolution, we looked at the causes of day and night, and we looked at why the hours of daylight change over a year's time. So at this point, you should have either taken notes or completed the study guide. If you have any questions about day or night, please make sure you get with your teacher and get your concerns addressed. So until next time, have a good day. Bye now.